This is the video of going over the spring final review. Remember, you can pause, rewind, fast forward, whatever's going to take to help you out. So this first problem, it says calculate the exact circumference of the circle. In order to do that, we need to find what our radius is. So since this is a right triangle, we can use Pythagorean theorem. 5 squared, 12 squared equals c squared. That's going to be the hypotenuse that we're looking for. So that's 25 and 144, which is 169. When we square root that, we'll find out the hypotenuse of the triangle is 13. If the hypotenuse is 13, the radius is going to be 13 divided by 2, which is going to be 6.5. That 6.5 is what we're going to use with the circumference formula. So 2 times 3.14 times the radius. When I put that in my calculator, 2 times 3.14 times the radius, I get 40.82. That's the circumference. Second one, finding the volume of this prism. And then we have this hemisphere in here that's cut out of it. So for the prism part of it, it's just going to be the volume is the base times the height. Our base is a 12 by 7 rectangle. So for the base, we're going to go 7 times 12. We get 84. Our height is going to be the 7 going from top to bottom, so from base to base. So for the volume, it's going to be 84 times 7. And that's the prism's volume. So 588. Then we have to find the volume of this hemisphere. So hemisphere, the volume is 4 pi r cubed divided by 3, and since it's only half of a sphere, dividing by 2. So the radius right here is not 7, because 7 goes from the very top to the very bottom. So the very top to the bottom would be a diameter. The radius is going to be 3.5. It's half of the height, since the height is the diameter of the circle. So 4 times 3.14 times the radius raised to the third power. And then we're going to divide by 3 and divide by 2. 4 times 3.14 times the radius cubed divided by 3 divided by 2. And that's 89.8. So for the volume of the figure, we get the 588 and we subtract 89.8. And we're left with 498.2. Here's your volume. On this one, it says calculate the length of arc RS. So we want this piece right here. Since it's a piece of the full circle, we're going to use the formula that goes (3.14), so pi, times the radius squared. That would be the circumference of the circle. Wait. Luckily, I caught that. Oof. It'd be 2 times 3.14 times the radius. That would be the circumference of the circle. And then multiply that by the 42 degrees, because that's the arc we care about, divided by 360 degrees, because that's a full circle. See what we get. 2 times 3.14 times 5 times the angle divided by 360. We get 3.7. And that would be meters. Next one, we've got this hemisphere that's stuck on top of the cylinder. So for the hemisphere, we're going to go 4 times 3.14 times the radius. This is your radius right here. Cubed. And then divide by 3. And it's only half of that sphere, so divide by 2. 4 times 3.14 times 7 raised to the third power. And if you don't want to do it that way, you can go 7 times 7 times 7. Then divide by 3 and divide by 2. We get 718.0. And then for the cylinder, it's going to be the circle. So pi times the radius squared times the height of the cylinder. So 3.14 times 7 squared times 11. 1692.46. So if we take this and we add the 718, you get 2,410.46, and it would be meters cubed. Number 5, we have two hemispheres. Sorry. 2 half circles. So we've got 2 half circles, and if you stick that together, we're going to have one full circle. And the radius on this thing is going to be 4, because that's a diameter, and we want the radius. If we're trying to find the area of the circle, that's pi r squared. So for the circle, we're going to go pi times the radius squared. Squared. 50.24. And then for this rectangle here, it's 6 times 8. And if you add those two together, you get 98.24. And that would be meters squared because we're talking about area. This one, it says, assume the segments that appear tangent are tangent. Remember that, like the Jack-in-the-Box head, these sides have to be the same, so it's 4 on both sides here. If this is 5, then this part of it, from here to here, that's also 5. And if that part's 5, and this whole side is 9, 9 minus 5 is going to make this side 4 over on this side right here, which means that x has to be 4. So we're looking for x. There we go. Number 7 says the length of the diagonal of a square is 7 square root of 2. It says draw the image. Even if it didn't say to do that, I would draw it. So we have a square. The diagonal goes this way. And it's saying that that is 7 square root of 2. Now, it's a square. If you think about just this side, we've got ourselves a right triangle here. If we want to know one of the sides, it's a square, all the sides are the same. We could use Pythagorean theorem. but this is also a 45, 45, 90 triangle. So I'm going to use the shortcut. If that's 7 square root of 2, this has to be 7. This also has to be 7. And if we want to find out the perimeter, it's going to be 7 here and 7 here. And if we add all 4 sides together, that'd be 4 times 7. That's going to be 28 feet for the perimeter. And it's a distance going around, so it would be feet, not feet squared or feet cubed. Number 8. Since this is an inscribed quadrilateral, the opposite angles are always going to be supplementary. So if I need to find angle C, for the measure of angle C, I'm going to go 180 minus the angle that's across. So 180 minus 97 is 83. That is an ugly 3, but it's a 3. We also have to find angle D over here, so that's across from 94. So for the measure of angle D, 180 minus 94. We got 86. Then we have to find arc AB, which is this piece over here. So if you know that this is 83, from D to B would be double this. So if we get 83, multiply it by 2, that's 166. We already know this side's 118, so if we get this 166 and we subtract away the side we already know, that means it's got to be 48 degrees for the measure of arc AB. Oh yeah, AB. We need that one. So AB. So AB is 48 degrees. Then the other question was asking about arc BD, which I already told you earlier. It's going to be double what this angle is because that is the inscribed angle for the intercepted arc. So that's where we got this 166 for the measure of arc BD. So here's the other 2 answers. Now over here you got to watch out because this looks like a rhombus, but the directions clearly tell you it's a kite. And because it's a kite, that means these 2 sides are the same. And then these 2 sides are the same. But they're not all 4 the same. Because it's not a rhombus, even though it looks like a rhombus. Now, on a kite, where these sides meet up that are not the same, those angles are going to be always equal to each other. So they're going to be congruent. They're going to be the same, 105. If you already know that's 105 and that's 105 and that's 73, in case you need this angle, you know it's 360 minus the 3 angles that you already know. This says calculate KE. Oh, geez. There is no KE on here. Well, let me show you what you can do with this problem. If that's 10 and I ask you for AD, that has to be 10 as well. If I ask you for DC, since this side is 12, that's also 12. You can see the marks right here that have the same amount of little tick marks. That's how you know they're the same. Like I mentioned earlier, if I give you this side is 70, this angle 73, you know these are 105s because they have to be the same. Then you can go 360 minus the angles you already know. And whatever's left over has to be the measure of angle C. So 360 minus 105, 73, and 105 we've got 77 degrees left over. So those are all the different things that I could ask you on that kind of a problem when it's a kite. I could ask you for the angle that's across this way. Remember, you have to find where the two different sides meet up, and those are going to be the same this way. And then if you need this angle over here, it's not going to be the same this way. So you have to go finding the three angles you already have and subtract them from 360. Kind of sneaky because it looks like a rhombus, and I know it does. Be ready. All right. Number 10. It says calculate the values of x and y in the parallelogram. Let me come over here. These two sides of a parallelogram have to be equal to each other. No matter what, these will always match on a parallelogram. Whether it's a rhombus or a parallelogram, opposite sides are going to be congruent. So you can go 4x equals 2x plus 10. Now you have an equation and you can work it out. Subtract 2x from both sides. You get 2x equals 10, so divide by 2, and x is 5. When we're doing y, we're going to do the same thing. This side is the same as this side. So 5y minus 2 equals 13. Now we're solving this. Add 2 on both sides. Divide by 5 on both sides. And you can find y. Number 11 says calculate the values of a and b. So this is where you got to use SOHCAHTOA, the trigonometry stuff. Because this is actually a 30, 60, 90 triangle, the shortcut is to go, okay, from this hypotenuse to the short side on a 30, 60, 90, you get this and you cut it in half. So you can just go 13 divided by 2 and find out this is 6.5. And that's quick. Once you know the short side, the long side is going to be whatever this is times the square root of 3. Like that. That's 11.3. So that's the short way. A is 11.3 and B is 6.5. If you forget that, SOHCAHTOA will work. So if we're coming through this problem as a SOHCAHTOA problem, I'll put that over here on the side. You'd go from this angle. If I want to work on A first, A is adjacent and 13 is the hypotenuse. So adjacent and hypotenuse would be cosine. The angle goes next to that. And on the fraction, the adjacent goes first and the hypotenuse goes second. And because the A is on the top, you're going to be multiplying 13 times the cosine of 30. If you do that, 13 times cosine of 30, you get that 11.3 that I got doing it this way. For B, that's going to be the opposite. And you'd go opposite with hypotenuse is sine. Then the angle still goes next to that. And on the fraction, opposite goes first. And the hypotenuse goes down to the bottom. Once again, you're going to be multiplying because the variable is on top. So you would go 13 times the sine of 30. Like that. And you get 6.5, which is what I got over here. So there's multiple ways to get your answers. One way or the other. Those are the answers. Number 12 says Bob is flying a kite on the end of a string that is 200 feet long. The angular elevation from Bob to the kite is 47 degrees. How high above the ground is the kite? So if we come over here, think about a kite. So the kite would be up here. Little string, little bow tie things. Okay, so here's my kite, and here's Bob. With long hair. And he's stepping on the string so that it's all the way on the floor. It says the string is 200 feet long. Well, this would be the string coming up. That's going to be the hypotenuse. We'll put H for hypotenuse. Angle of elevation is 47 degrees. That's going to be where his foot's at. And then the question's asking how high above the ground is the kite. So that's going this way. That's the triangle you're dealing with. Now you look at it like a SOHCAHTOA problem. From here, that's your opposite, which would be your O. That's your hypotenuse. Opposite and hypotenuse, we're back to sine. The angle goes next to that, so it's 47. On the fraction, opposite goes on top. We don't know that. Hypotenuse goes on the bottom. That's the 200. Since it's on top, we're going to be multiplying. So in the calculator, it's going to be 200 times the sine of 47. $146.3. And that would be feet. So continuing on. This one says solve for MP and NP. So MP over here, if I'm working on this one first, this would be the hypotenuse. MP from here would be adjacent. Adjacent and hypotenuse. That's cosine. Angle goes here. Adjacent goes on top. Hypotenuse goes on the bottom. So this time, we're dividing. It's going to be 4 divided by the cosine of 25. That's 4.4. So MP is 4.4. If we're doing NP, that's opposite. And we've got to use the number we already had, which was the adjacent. So opposite and adjacent, that's tangent. Opposite's going to go on top. Adjacent's going to come down to the bottom. This time the variable's on top, which means we're back to multiplying. We get 1.9. So NP 1.9. There's that one. Number 14. It says in this circle, segment FB and AD are diameters. Good to know. That means the top's 180, the bottom's 180. It says FGE right here. EGD right next to it, over here. DGC, this one over here. And CGB, this one over there, they're all the same. Which means that the 180 degrees from F to B is going to get split by 4 angles. So that's going to be 45 degrees each. It says calculate the measure of AC. So if we're going from A to C, that's going to be the 90 degrees from here and the 45 from there. So AC is going to be 135. This one says, is the dilation from ABCD to EFGH an enlargement or a reduction? So you have to figure out which one's the beginning. So ABCD is where you start. And then it got smaller and it ended at EFGH. So that means that it started big and it got smaller. So that would be a reduction. When it comes to the scale factor, if you find one of the sides from A to D over here is 2, and from E to H over here is 1, then your scale factor is just the relationship between those. But since it got smaller, it's a reduction. That means that we go this way. If you multiply any of these sides times this scale factor, it should give you the corresponding side. So like, for example, over here on the top of it, from A, let me switch colors. From A to B, going this way, from a -1 to a +5, that'd be 1, 2, 3, 4, 5, 6. If we multiply that by 1/2, then this is going to be 3. And if you look, from a 1 to a 4 is 1, 2, 3 spaces. So it works. Number 16, what are the coordinates of the vertices after a 180-degree rotation? If it's a 180-degree rotation, you're going to go, okay, this went 1, 2, 3, 4 up. We're going to go 1, 2, 3, 4 down. If this was 1, 2, 3 to the right and 2 up, we're going to go 1, 2, 3 to the left and 2 down. So that would be A prime. This would be C prime. And then for B, 1, 2, 3 to the right, 1, 2, 3, 4 up. So 1, 2, 3 to the right, 1, 2, 3. Oh my gosh, it's hard to see. 4 up. And we would end up with a little triangle that looks like that. That'd be upside down. So the coordinates on this thing, if it's 0 left and right and it goes down 1, 2, 3, 4 spaces, A is 0, -4. For B, we went 1, 2, 3 to the left, 1, 2, 3, 4 down, 3 to the left, and then 4 down. When it comes to C prime, we went 1, 2, 3 to the left and 2 down, 3 to the left and 2 down. There's that page. And the last page. There's actually only 2 problems left. It says, what's the equation of this circle? So if you find out the radius, 1, 2, 3, 4 spaces. And you find out your center. So this is 1 to the left, 1, 2, 3 up. So -1, +3. The formula for the circle is x minus h squared plus y minus k squared equals r squared. Your h is the -1, your k is the 3, and your radius, the r, is 4. You're going to go x minus -1, so it's going to be +1. Y minus the k, which is 3. And then the radius squared, 4 squared is going to be 16. Last problem. Describe the transformation from triangle ABC to triangle A prime, B prime, C prime. So if we started here, it's rotating. No, it's sliding. So first it translated. And if you follow one point, it's going 1, 2, 3, 4, 5 to the right and then it's going 2 down. So that's the first thing that happened. After it got there, this is reflected across the x-axis. So if you think of this as a mirror, then that's what happened. So reflected across, and this line's called your x-axis, so reflected across the x-axis. That's what happened on this transformation.